Okay, today we're going to continue to solve systems of equations, but we're going to learn a new method. So far we've learned how to solve by graphing, and to solve by graphing you have to have a graph. And then we learned how to solve by substitution, and to solve by substitution you need to have one variable all by itself on one side of the equal sign. And now today we're going to learn about how to solve by the method of elimination. Now to solve by elimination, you have to have a couple of things. First of all, you have to have all of your terms lined up. We want the x term to come first, the y term to come second, and the constant to be by itself. So I want the x's on top of the x's, the y's on top of the y's, the equal signs on top of the equal signs, and the constants on top of the constants. Now the goal of elimination is to make one of the variables go away. We want to eliminate one of the variables, and we're going to do that by adding the two equations together. Now, if we have everything set up correctly, one of the variables will just completely disappear and we'll only have one variable to work with. So that means we also have to have one of the variables that has the same coefficient, so the same number in front of it, and different signs. So if I look at my x variables, they both have the same coefficient. They both have a 1 in front of it, but they have the same signs, a positive and a positive. So if I add them together, they won't disappear. Now my y's have the same coefficient. We have a 1 and a 1, but they also have different signs. So that's good. That means when I add them together, they'll eliminate. So how we do this is we're going to old school add. So if you remember when you first learned how to add and subtract, you would do it the old school way. You would say like 2 plus 5 equals 7. And we're going to do the same thing, but now with equations. So we're going to draw one big line underneath our two equations, and we're going to add them together. So 1x plus 1x will give me 2x. Negative 1y and positive y cancel out. I'll bring down my equal signs. Oh, I don't know why I changed colors. Let's try that again. I'm going to bring down my equal signs, and 1 plus 3 is 4. Now 2x equals 4 is a much easier equation to work with, so now I can divide each side by 2, and 4 divided by 2 is 2. Next, to solve for our variable, we need to take, or to solve for our y, we need to take 2 and substitute it back into one of my two original equations for x. So I want you to show exactly how you substitute it. I want you to circle that 2 and draw an arrow to exactly which x you're going to plug it back into. Now it doesn't matter which equation you choose, you should get the same results either way. So if I take this 2, I would rather substitute it into the bottom equation than the top equation. So I'm going to draw an arrow exactly to that x, and I'm going to rewrite my new equation. So instead of x plus y equals 3, I'm going to have 2 plus y equals 3. And to solve, I'm going to subtract 2 from each side. And if I subtract 2 from my left side, I'll be left with y. And if I subtract 2 from my right side, I'll be left with 1. Now I need to write them as an ordered pair, x comma y, so my answer is going to be 2 comma 1. Alright, let's try it again on number 2. We first want to make sure everything is lined up and good to go. So I have x's on top of x's, y's on top of y's, equal signs on top of equal signs, and constants on top of constants. So if I add them together, I want to make sure one of the variables disappears. So let's start with the x's. They both have the same coefficient. I have a 1 and a 1, and they have different signs. I have a negative and a positive. So right away I know that I can add these together and the x's will go away. So a negative 1 plus a positive 1 cancels out. Then I have a positive 1y and a positive 1y, so 1y plus 1y is 2y. And then I have 1 and 11, add those together and I get 12. So now to solve for y, I can divide each side by 2, and y is going to equal 6. Finally, I need to solve for x, so I want to take this y and substitute it back into one of my two original equations. If you'll notice, this x is negative and this x is positive, so this one looks a little bit easier to work with. So I'm going to draw an arrow and just say that I'm going to substitute 6 back in for that y right there. So instead of x plus y equals 11, we'll have x plus 6 equals 11. Now I can subtract 6 from each side. If I subtract 6 from the left side, I'm left with x. And if I subtract 6 from the right side, I'm left with 5. Substitute those in, goodness gracious. We're going to create an ordered pair for our answer here. So x comma y is going to be 5 comma 6, and I want to box my answer. Alright, on number 3, I want to first make sure everything is lined up and good to go. So x's on top of x's, y's on top of y's, constants on top, or goodness, equal signs on top of equal signs, and constants on top of constants. Now, I want to ensure that they will eliminate when I add them together. So if I look at just the x's first, they have the same coefficients, they're both 2. One's positive and one's negative, so that means when I add them together they will go away. So let's go ahead and try it out. So if I draw the line underneath, a positive 2 and a negative 2 cancel out, and a positive 3 and a negative 3 also cancel out. That means I've got nothing left on my left side. Well, that's okay because we know a number that represents nothing, and that number is 0. Now on my right side, I've got a positive 8 and a negative 8. Well, a positive 8 plus negative 8, those cancel out and also leave me with 0. Now if you'll remember, whenever you're solving and you run out of variables and you only have numbers left, you have two options: infinite solutions or no solutions. And to determine which one is true, you have to ask yourself, is this a true statement? Does 0 really equal 0? And it definitely does. That means it is infinite solutions. I-N-F-I-N-I-T-E. Infinite solutions. So that means any ordered pair will work. These two lines would be the exact same line. So on number 4, I want to first make sure they're lined up. My x's on top of my x's, y's on top of y's, equal signs on top of equal signs, and constants on top of constants. Then I want to make sure that if I add them together, something's going to eliminate. Let's start with the x's. They do have the same coefficient, which is good, and then one's positive and one's negative. So that means that if I add them together right away, they'll cancel out. So let's do that. 12x and a negative 12x cancels out. A negative 3y and a positive 3y cancels out as well, which means I have 0 left on my left-hand side. On my right-hand side, I'm left with 1 and 5. Well, 1 plus 5 is 6. And again, notice I have no more variables. All my variables are gone. So that means I just need to ask myself, is this a true statement? And it's definitely not. 0 does not equal 6. So let's cross out that equal sign. And that means that my answer is no solutions. And again, make sure to spell it out. We don't use any symbols. Okay, on number 5. First of all, I want to make sure that everything's lined up. So x's on top of x's, y's on top of y's, equal signs on top of equal signs, and constants on top of constants. So now I'm going to go through and make sure that if I add them together, something's going to eliminate. So my x's, they do not have the same coefficient, so that's not going to help me. Let's go to the y's. Those also don't have the same coefficient, so that's going to make it a little bit tricky. When that happens, now what we need to do is we need to see if we can turn one coefficient into the other. For example, if I start with my x's, using multiplication, can I easily turn a 2 into a 1? And that's not very easy because I would have to actually divide, and that's not what we're looking for. But using multiplication, could I easily turn a 1 into a 2? And I can. I can do that by multiplying it by 2. So what I'm going to do is I'm going to manipulate this entire equation to make it easier to go away. So to turn it into a 2, I'm going to multiply the whole equation by 2. But remember, not only do they have to have the same coefficient, they have to have opposite signs so that they'll cancel out. So since this one's positive, I want to make sure this is a negative 2. So I'm going to multiply everything by negative 2. Now, when I multiply by 2, here's what I need to do. I need to distribute to every single term inside of those parentheses, and I want to rewrite my brand new equation over here to the right. Don't go down. We're going to rewrite the equation over here to the right, which will make more sense in the future. So let's start with negative 2 times x is going to give me a negative 2x. Negative 2 times 2y gives me a negative 4y. And then negative 2 times 5 gives me a negative 10. Now, this equation up here that I did nothing to, it's still going to stay the same. I'm going to bring it straight over. I'm just going to rewrite it. So 2x plus 3y equals 6. It's going to go right up there on top of the other one. Now, I've got these two equations that I'm going to work with. They're all stacked on top of each other, nice and neat and ready to go. I can ignore these. I'm done with them for now. So, to add these two together, if I have a 2x and a negative 2x, those go away. If I have a 3y and a negative 4y, that's going to leave me with a negative 1y. And then a 6 and a negative 10. Add those together and I'm going to get negative 4. Now, if negative 1y equals negative 4, I can divide each side by a negative 1, and that's going to change the signs and give me y equals 4. Now, since y equals 4, I can substitute this variable back into one of my two original equations. I don't want to substitute it into my new one, just in case I did something wrong. So, I want to draw an arrow to exactly where I'm putting it in. And I'm thinking this bottom equation looks easier than this top equation, so I'm going to draw an arrow to this y right here. So, when I substitute that in, the x stays the same, and I'm going to add that to 2 times 4, and that's going to equal 5. Now I can multiply those two together, and I'm going to get x plus 8 equals 5, and subtract 8 from each side. So if I subtract 8 from my left side, I'm left with x, and if I subtract 8 from 5, I get negative 3. So that means my answer in ordered pair is x comma y, so that's going to be negative 3 comma 4. Alright, on negative 6, if I look, everything's lined up. Now if I add them together right away, nothing is going to eliminate because these are different signs, but they're also different coefficients. These are the same signs and different coefficients. So I need to figure out what I'm going to have to multiply by in which equation. Now using multiplication, again, it's very difficult to turn a 2 into a 1, but I can easily turn a 1 into a 2. So I want to multiply the second equation by 2. Notice that this is different than the previous equation because this one's already negative. I don't have to multiply it by negative 2. I can leave it as positive. So what I'd like you to do now is pause the video and come up with your two equations over here on the right-hand side. So when you distribute, your top equation is definitely going to stay the same, 2m plus 3n equals 4. But distributing that 2 in the denominator, in the bottom equation, we're going to get negative 2m plus 4n equals 10. Now when I add the two equations together, let's see what we get. 2m and negative 2m cancel out. 3n and 4n give me 7n. And then 4 plus 10 gives me 14. Now I can divide each side by 7. And n is going to equal 2. Now all I need to do is substitute it back in to solve for m. So I'm going to circle it, and I think I want to go with the bottom equation. Now again, it doesn't matter which equation you choose. If you pick the top equation, you should get the same result. So negative m plus 2 times 2 equals 5. Well, 2 times 2 is 4, so negative m plus 4 equals 5. Subtract 4 from each side. Negative m is going to equal 1, which means m is going to equal negative 1. Now, to determine your final answer here, to write it as an ordered pair, it's a lot easier when it's x's and y's, but this is m's and n. So, to write your answer, you need to write it in alphabetical order. So, x comma y is in alphabetical order. If you were working with A's and B's, it would be A comma B, or C comma D, or P comma Q. Since we're dealing with M's and N's, it's going to be M comma N. So I want negative 1 comma 2. Okay. On number 7, I have x plus 4y equals 11 and x minus 6y equals 11. So everything's lined up, but right away, if I add these two equations together, nothing's going to cancel out. Now, if you pay attention, on the x's, we do have the same coefficient, they're just not different signs. So this one's really easy to work with. I just need to pick one of my two equations. I'm going to pick the bottom one. And I just need to change the sign in front of the x. So that's really easy to do. I'm just going to multiply this bottom equation by negative 1. So my top equation is going to stay the same, x plus 4y equals 11. And my bottom equation is going to be multiplied by negative 1. So negative 1 times x is negative x. Negative 1 times negative 6y is positive 6y. And negative 1 times 11 equals negative 11. Now what I'd like you to do is pause the video and finish solving this entire problem on your own. So when you solve, you should add them together and get 10y equals 0. Now remember, 0 is a number. So if 10y equals 0, that means y equals 0. Substitute it back in and you should get x equals 11. So your answer is 11, comma 0. Next, what I'd like you to do is pause the video and try number 8 all on your own. Okay, hopefully you decided to multiply the bottom equation by 2, and that's going to give you a new equation of negative 4f plus 12g equals 6. When you add them together, you're left with 0 equals negative 2, which means that we have no solutions. Next, we're going to talk about some word problems. Now, the instructions of the word problems are pretty important. It says, define your variables, then set up a system of equations to solve each situation. So on number 9, it says the sum of two numbers is 28, and their difference is 4. What are the numbers? Well, I don't know what the numbers are, so I have to call them something. So let's just talk about the first number. Since I don't know what the first of the two numbers are, I need to call it a variable. Well, our favorite variable is x, so I'm going to say that x represents my first number because I don't know what it is. Well, if I don't know what the first number is, I don't know what the second number is, so I'm just going to call that guy y. Y is going to represent my second number. Now, you can call them whatever variables you want. I just chose x and y because they're easy to work with. Now, it says the sum of two numbers is 28. Well, sum means addition, so I want to add these two guys together, and that means I'm going to get a result of 28. Their difference is 4, so that means if I subtract them, I'm going to get 4. So I'm going to keep it in the same order, that x minus y, and I'm going to get 4. Here I now have a system of equations, and they're all lined up and ready to go for elimination. Notice the y's have different signs and same coefficients, so right away they're going to cancel out. So x and x is 2x, y's cancel out, 28 and 4 is 32. Now to solve for y, or x, I'm going to divide each side by 2, and x is going to equal 16. Finally, to solve for y, I'm going to take the 16 and substitute it back into one of my two original equations. Now, if you'll pay attention, this y is positive, this y is negative. I would much rather deal with a positive number than a negative number, so I'm going to substitute it into the top equation. So that's going to be 16 plus y equals 28. I'm going to subtract 16 from each side, and y is going to equal 12. That means x equals 16 and y equals 12. Now on the previous problems, we were working with problems. They gave us the equations, we just had to solve them. And when we did that, we wrote our answer as an ordered pair. This, however, is a word problem. And on these word problems, we had to come up with our own equations because they typed out what they're doing. That means that we need to write out our answer and what it means. We can't just say x equals 16 and y equals 12. We have to talk about what x and y represented. Well, x represented the first number and y represented the second number. So we need to say the first number is 16 and the second number is 12. Okay, let's try it again on number 10. Find two numbers whose sum is 29 and whose difference is 15. Well, again, I don't know what those numbers are, so I have to call them variables. I'm going to let x represent the first number that I don't know, and y is going to represent the second number that I don't know. Now, I need to come up with two equations. So my first equation, it says the sum is 29. So that means I'm going to add them together and get 29. And their difference is 15. That means I'm going to subtract them and get 15. So when I do that, I have a system of equations which are good to go for elimination. So I'd like you to pause the video, solve this problem, and then we can come back and write the sentence together. So when you solve, you should get x equals 22 and y equals 7. That means for our sentence, we need to describe what those numbers represent. Well, that means that the first number is 22, and the second number is 7. Alright, on number 11, it says the Harrimans ordered 2 hamburgers and 3 hot dogs for $7.05. The Befforts ordered 2 hamburgers and 2 hot dogs for $5.76. How much did each item cost? Well, we first have to figure out what we don't know, and they want to know how much did each item cost. Well, what items are we talking about? We're talking about hamburgers and hot dogs. I don't know how much they each cost, so that's going to be what I need to define. So I'm just going to use X and Y again. I'm going to let X represent hamburgers, but I have to be specific. I can't just say hamburgers because I don't know what's happening with the hamburgers. Is that how many hamburgers they ate, how many they ordered, how many they made? X represents the cost of hamburgers. That means Y is going to represent the cost of hot dogs. Now that I have variables to represent my unknowns, I can use them to write an equation. So the first sentence says the Harrimans ordered 2 hamburgers, so I can say that's 2x, and 3 hot dogs, so 2x plus 3y, for $7.05. So that's going to equal $7.05. Now the Befforts ordered 2 hamburgers, so 2x, and 2 hot dogs, so 2y, for $5.76. So now I have my systems of equations, and they're lined up for elimination, but if you'll notice, nothing's going to cancel out. Now my x variables have the same coefficients, but they don't have different signs. So that means I'm going to have to multiply one of the 2 equations by a -1. Now I'm just going to choose my bottom equation here because it looks a little bit easier. However, if you think about it, when you multiply anything by -1, it's not actually changing the number, it's just changing the sign. So instead of multiplying by -1 and coming over here and writing the new equation, let's just go through and change all of the signs of my second equation. So this guy's going to be negative, this guy's going to be negative, and this guy's going to be negative. Now I can add them together with a little less work. So the 2 x's will cancel out, 3y and -2y is going to give me 1y, and then 705 minus 567, I can do that in my calculator. 705 minus 567. And that's going to give me $1.38. Oh, it should be 576. I messed that up. I'll try that again. 705 minus 576. 705 minus 576. That's going to give me 1.29. That sounds better. So 1.29. And just a reminder, that represents the cost of a hot dog. So one hot dog costs $1.29. Now I have to find the cost of a hamburger, so I need to substitute this guy back in. I'm going to put it back into my first equation because I haven't messed with it yet. So I'm going to say that 2x plus 3 times 129 is going to equal 705. Now I can multiply, so in my calculator 3 times 129 is going to give me 387. So 2x plus 387 equals 705. Now I need to subtract 387 from each side, so 705 minus 387 gives me 318. So 2x equals 318. And then I need to divide each side by 2. So if I take that 318 divided by 2, I'm going to get 1.59. So x equals 1.59. Now remember, x represents the cost of a hamburger, so that means a hamburger costs $1.59. Finally, we just have to write our answer in a sentence. And all we have to say is what each one is. So it says how much did each item cost? A hamburger costs $1.59. And a hot dog costs $1.29. Alright, on number 12 it says 5 hard tacos and 8 soft tacos cost $17.15. 5 hard tacos and 2 soft tacos cost $8.75. Find the cost of each kind of taco. So they want to know, what is the cost of each kind of taco? I have hard tacos and soft tacos, so those are going to be my variables. Now, we could call them X and Y, but I'm going to choose some variables that kind of represent our numbers a little bit easier. So instead of X for hard tacos and Y for soft tacos, I think H would represent hard tacos just a little bit better. But remember, we have to be specific. It's not like how many hard tacos there are, it's the cost of a hard taco. And then I'm going to use S to represent the cost of a soft taco. Now be careful, because you need to make sure your S doesn't look like a 5. So make sure it's nice and curved. Now I can come up with my two equations. The first one is 5 hard tacos, so that's going to be 5H, and 8 soft tacos, so 8S, cost $17.15. My second equation is going to be 5 hard tacos and 2 soft tacos, costs $8.75. So here it is, all lined up and ready to go for elimination, but again, nothing's going to eliminate. I can easily make my H's eliminate if one of these was negative. So I'm just going to choose one of the two equations. I'm going to choose my second one and just change the signs in all of those terms. Now what I'd like you to do is pause the video and solve on your own. Alright, so when you solve, you should get S equals 1.4, which really represents 1.40. And then we can substitute it back in and get H equals 1.19. And that means that a hard taco costs $1.19 and a soft taco costs $1.40.